All right, is everybody ready to go? Yes, Professor, we are. Okay, great. Okay, part E. Oh, these LNs are kind of fun. These are a little bit different. Um, so if you notice that the logarithms are no longer on the same side, they're kind of like A and B, they're separated, but there's that extra number hanging out there. That plus 2, that's not in the LN. There's no parentheses surrounding the x plus 2. So in this situation, we're going to try to make this equation look like C and D. So I'm going to move the ln of x to the left side. And just like I did before when I had that minus sign, I'm going to turn it into division. And I'm still going to turn it into exponential form. Now remember, ln is the same thing as log base e. So I have whatever's inside the log, so x plus 3 over x, and then it's going to be e squared over here on the right. Now don't panic because you have an e squared. Like, that's still just a number. So don't think you're getting it wrong or you're going in a wrong direction. Like, that's okay. You can have things in terms of e, just like you can have things in terms of pi. So I'm still going to cross multiply it. So x plus 3 is equal to x e squared. And just for fun, let's put the x's over on the right. You know, it doesn't matter what side you pull them to, but the xe squared looks a bit more complicated than the x, so I'm going to leave it where it is. All right, so now all your x's are together on the same side. So let's pull an x out. And now we can divide by e squared minus 1. Okay, and you guessed it, we still have to check our answer and make sure that it gives us a positive result. So how do you know if it will if you can't use a calculator? So we kind of have to reason our way through it. So e squared minus 1, that's going to be a positive number because e is about 2.7. So if I squared that and subtracted 1, that's going to give me a positive. It's going to be like around like 7 or 8. So that means this fraction, I have a positive over a positive, which makes the fraction itself positive. So if I plug it in for that x, that's positive, that's okay. A positive number plus 3 is still positive, so that's okay too. So I get to keep this solution. All right, let's move on to this one. Oh, now this one, what some of you might be tempted to do is you like, oh, that's an exponent, I can pull that down. Well, with this one you can't, because the square is going with the entire function. It's not just on the x. So if it was this, if it was ln of x squared, then you could pull it down. But if it's going with the whole thing, it can't do that. But if you look at it, this is really like a quadratic equation in disguise. It's quadratic and logarithmic. It's both at the same time. So typically when you have two types of equations and one of the types is quadratic, you got to solve the quadratic first. So we're actually going to factor this into ln of x minus 4 and ln of x minus 2. So ln of x would equal 4 and ln of x would equal 2. So then if you change it around to exponential, just like we did over here, remember this is log base e, so x is going to equal e to the 4th, and it's also going to equal e squared. And if I checked them both, that gives me a positive, so they're good to go. Okay, let's go ahead and move on to some exponential functions. So that's kind of pretty much it for the logs. But exponential, the there are a couple of ways we can go. One of them, one way that you want to go for sure is go, hey, do they have a common base? Because if they do, then once you find that common base, they'll drop out. And then you just solved it without having to do anything too crazy. So for part H, 8 and 32, their common base is 2 again. So 8 is 2 to the third. 32 is 2 to the fifth. Distribute. Distribute the 5. Now you can drop the 2's out and solve 12x minus 9 equals 10 minus 15x. So let's put the x's on the left. Oops. X, not z. Not sure where I wrote that. Move the 9 over. And so x is going to equal the fun number of 19 over 27. Now with exponentials, you don't really have to check your solution. If it was a logarithm, then you do. All right, let's go ahead and pause the video here, and then we'll finish off with some more complicated examples.